Hello and good evening. This is Samuel Anekan. Welcome you to this channel. It is Samuel the Creator's channel. So in this video, we'll be looking at logarithm, application of change of base in solving logarithm problems, in simplifying logarithm expressions and equation. So if you're not subscribed to this channel, please hit the subscribe button and hit the like button and share this video with your friends and loved ones. So right away, we're going to move to the lesson. Hello, good evening. Welcome to this channel. This is Samuel and I can welcome you. In this video, we'll be continuing on our series on logarithm. In this particular logarithmic tutorial, we will be looking at how to apply change of base. There are scenarios whereby to simplify a log, you have to actually change the base, apply what they call change of base. So follow along as I explain and show you. So let's assume that you have if log p to base x is equals to log p to base b is equals to x, and we need to simplify this. Log p to base b is equals to x, and we have to simplify this. So how are we going to simplify? What we're going to do here is we'll apply what we call change of base. But before we apply change of base, how are we going to go about it? Let's change this to the index form. So in the index form, which I explained in my previous video, in case you missed that tutorial, I would like you to go over it, where I actually show you how to go from the logarithmic form to the index form, and from the index form to the logarithmic form. So in the index form, this is the logarithmic form. In the index form, this is going to be p is equals to b raised to power x. In the index form, the base still remains the same. Here in the logarithmic form, the base is b. In the next form, the base is still b. Okay. Now we have this. So we're going to take log of both sides, log of the left hand side and log of the right hand side, to the same base. So the new base we are introducing is base c. This base c must have a connection between b and p. When you are actually solving, there must be a connection between b and p. If not, you will only end up complicating matters. So how do we do that? So we're going to take the logarithm of p to base c and the logarithm of b raised to power x to base c as well. Okay, so from here right now, this can be simplified as x, the power x can come behind the log b base x log p base c. This is base c, sorry, log b base c. The index here has dropped down behind the log. So from here right now, x is equals to the log of this, of p base c, over the log of b base c. So x is equals to the log of p base c over the log of b base c. So this is originally x was what? X was equals to log p base p. So we can say that log p base c over log c log b base c is equals to x, and x is equals to log p base b. So when you have a log p base b, you can actually, to simplify this further, if they have a base that is common, a common base that is common to b, that is related to p and related to the current base b, you can actually change the base, and it will enable you to simplify the logarithm that you have, such that right now our new base, which is related to p and which is related to b, is base c. So we have log of p base c, log of b base c. So this is change of base, and I'm going to apply it to two examples right now. So let's look at a scenario. Let's look at a scenario. Simplify the log of 8 base 4. We want to simplify the log of 8 base 4. Now, we can't simplify this the way it's reading, but if we apply change of base, we can actually simplify. So is there any connection between 8 and 4 in index form? Yes. 4 is 2 times 2. So 4 is equals to 2 raised to power 2. 8 is 2 times 2 times 2. 8 is 2 times 2 times 2. So 8 is 2 raised to power 3. So 4 is connected to base 2, and 8 also is connected to base 2 as well. Both 4 and 8 are both connected to base 2. So we can introduce change of base. The new base we're introducing is a base that is common to both 8 and 4, which is 2. Base 2 is common to 8, base 2 is common to 4. So that will be our new base. So this can be written as log 8 to base 2, which is our new base, log 8 to base 2 all over log 4 still to base 2. Okay, so right now base 2 base 2 base 2 is related to 8, base 2 is related to 4. So how do we go ahead to simplify this? To simplify this, we're going to say log 8 can be written as 2 raised to power 3. So we can say log 2 raised to power 3 base 2 all over log 4 can be rewritten as 2 raised to power 2. So we can say log 2 raised to power 2 base 2. Okay, so simplifying further, this can actually be written as, we can take the index behind the log, take 3 behind the log here, and take 2 behind the log here. So you have 3 log 2 base 2 all over 2 goes behind the log, 2 log 2 base 2. So we can say log 2 base 2 cancels log 2 base 2. That way, that is one way we can go ahead to solve. And we are going to end up with 3 over 2. Or we can say, we know that from the laws of logarithm I gave you, I set the log of a number to the same base. Log of 2 to same 2 is 1. Log of 2 to same 2 is 1. So this gives you 3 times log of 2 to base 2 is 1. This is 2 times log of 2 to base 2 is also 1. So 3 times 1 is 3. 2 times 1 is 2. So final answer is 3 all over 2. As simple as that. As simple as that. So remember, I said at the beginning that when you want to solve, you want to apply change of base. Here originally, there was no way we could solve this. We could solve this. But we know that 8 is related to base 2. 8 is the same thing as 2 raised to the power 3. And 4 is also related to base 2. 4 is 2 raised to power 2. So that was why we could apply the change of base concept here and solve. Okay, so I'm going to solve one more example before I call it a day today. So let's assume we have 9 log 9 to base 27. We have log 9 to base 27. Or let me change it to log 27 to base 81. Simplify log 27 to base 81. So how are you going to simplify this? Do 27 and 81 have a common base? Yes, they have. 27 is equals to 3 raised to power 3. That is 3 multiply itself 3 times. While 81 is equals to 3 raised to power 4. That is 3 multiply itself 4 times. So they have a common base we can actually use to apply the change of base concept, the change of base formula. So what do? We introduce the change of base right away. So how do we do that? You just come here and it's going to be log 27. Our new base will be base 3. Base 3, base 3. So we're going to have log 27 to new base 3 over log 81 to base 3. So now we're going to replace 27 with the index form and 81 with the index form. So we're going to replace 27 with 3 raised to the power 3 and 81 with 3 raised to the power 4. So we have log 3 base 20, log 27 is 3 raised to the power 3. While log 81 is 3 raised to the power 4. So 3 raised to the power 4 to base 3. So at the end of the day, take the index behind the log. 3 is going to go behind the log. You have 3 log 3 base 3. Then 4 is going to go behind the log as well. So you're going to have 4 log 3 base 3. So log of 3 to base 3, log of any number to the same base, to that same number in the base is 1. Okay? So the same thing here, log of 3 to base 3 is 1, log of 3 to base 3 is 1. So at the end of the day, you have 3 all over 4. Final answer. It's as simple as that. It's just as simple as this. Just as simple as this. Okay, let me try do one more example that looks a little different, so that in case you encounter such, it's not going to be a problem to you. So, in this case here, I wanted to simplify root 8 to Let's see. Let's see. Okay, let me check it. Let me check it out. Okay. Root 125 to base 25. Root 125 to base 25. So, in this instance, how do we solve this? How do we proceed? So, what we're going to do is that we know that root 125 is the same thing as 125 raised to power half. It's the same thing as 125 raised to power half. Okay. So with that, we can actually take the half. So we can actually write this as log 125, take the half behind the log. Okay. So right now, you have 25, you have 125. Log of 125 to base 25. You have the half behind. Okay. So now, is there any connection between 25 and 125 in index form? Yes. 25 is equals to 5 raised to power 2. That is 5 times 5, 2 times. While 125 is equals to 5 raised to power 3. So we're going to replace, before we replace, so base 125, 5 is common to 125. Base 5 is common to 125 and base 5 is also common to 25. So right now we're going to apply the change of this thing. So we're going to have log 125 to base 5 all over log 25 to base 5. Okay. So right now, you have half. This is log 5 raised to power 3. This is log 5 raised to power 2. At the end of the day, you're going to have, this is half, this is 3 log 5 base 5, this is 2 log 5 base 5. So at the end of the day, log 5 base 5 is 1. Log 5 base 5 is 1. Log 5 base 5 is 1. So you end up with a half 3 all over 2. So this cancels this. This is 1, this is 1. So 1 times 3, you have 3. 2 times 2, you have 4. Final answer. That is our final answer. So with this example, I've come to the end of our lesson for today. So just pick some examples and try your hands on them. So watch out for our next lesson. Bye bye. Thank you for watching the lesson to the end. So please, if you're not subscribed, make sure you subscribe and like the video. In case you have any question, you can drop in the comment section. or drop it on our WhatsApp number. In case you need a one-on-one online class, you can connect with me and I will give it to you. So please join us for the next class. And you can share the video with your friends and loved ones as well. Thank you. Bye-bye.